So, of course, some of these problems we're getting into a little bit of a weird territory, but that's okay. So what would you like to pick? And then I would like to look at the word problem.
55.
55. So we want to continue. Is that what you said? 55?
Yes.
Perfect. Okay, so let's work on 55. I'm going to move on to the next page. I don't have enough room there anyway. So 55, let me copy it and I'll stop sharing. Where is it? The integral from 1 to e, x plus 1 over x dx. We should always ask ourselves, is this function continuous? Yes, this is always continuous, and this is not continuous at 0, right? Only 0 is the problem, but 0 is not in the interval. If 0 were in the interval, so for example, don't change anything, but if I have this, I'll say FTC not applicable. Because 0 is between -1 and e, and this function is not continuous between -1 and e. But the integral is from 1 to e, from x plus 1 over x dx. So all I have to do is find the antiderivative, the most general antiderivative, without a c, of course. And in case you are wondering why without the c, let me explain. So if we have the integral from a to b from f of x dx, we could say this is f of x plus a constant c, but it has to be evaluated from a to b. Now look what happens. When I plug in b, f of b plus c, minus when I plug in a, minus c. That's why it disappears. That's why the c is not relevant when we have a definite integral. Okay, so can anyone tell us, you already told me that x squared divided by 2 prime will be this, plus. Can anyone tell us what function prime will give us 1 over x?
Natural log.
Very good, awesome. So it's natural log of the absolute value of x, but since between 1 and e are positive numbers, we can eventually skip the absolute value. So I write the equal symbol with a circle, jump over this, and continue here so that I don't start from the beginning. When I plug in e, I have e squared over 2 plus. Can anyone tell us what is natural log e? What does it equal to when I plug in e in here?
1.
Very good. Minus. It's better to put parentheses. When I plug in 1, I get 1/2. Plus, when I plug in 0, how much is how much is natural log 1? Okay, 0. Sorry, I said it before I asked. So then this is e squared over 2 plus 1 minus 1/2 is plus 1/2. And this is it. Yes, you can approximate it if you want to. Any questions here? Any questions? Is there anything else? Can we look at our problem now?
Yes.
Okay. So I don't know, total revenue, increasing total cost, increasing total profit. Be very careful. I'm not very happy with this function. Look what happens here. They say total profit. They give a function that is profit. But look what they ask. I mean, so it makes no sense. So in order to create a new version of the book, they change 3 letters or 3 words somewhere, but they don't even look that they are talking about profit, but all of a sudden they say, find the cost. How do I find the cost if you give me the profit, the rate of change of profit? but not the rate of change of cost. So be careful. We hope not to encounter those, but they are here. So they changed 3 words. Okay. But they didn't change the function. Okay. So we can,
means you.
which one?
That means we cannot calculate that.
But how can, if you don't give me C prime, how can I calculate C? You have to give me C prime. If you give me P prime, how can I calculate C? You have to ask me to calculate P. I cannot find the cost if you give me a totally different function. So, and then says find the extra profit. So it goes back in part B, it goes back to profit. Let's not waste time on that question. So business increasing total cost, okay. Kitchens too, please, fine. Contracting determines that the marginal cost, okay, that's okay. So they said marginal cost and they're giving us C prime. And it is dollars per square foot. Remember a second ago, they said that C prime is in dollars. Now here they're saying correctly that C prime is in dollars per square foot. So on the previous problem that we just worked on, they really meant C, not C prime. Okay, so be careful. I'm sorry about the book is not 100%. So would you like to work on 61? Is that okay?
Yes.
Okay. So I'm on page 6. So let's look at 61. So 61 they're giving us the marginal cost, that's fine, which is 4 times x to power 1/3. So the marginal cost, that's correct. It's a rate of change, has to have 2 measurement units per square foot. It's dollars per square foot of installing x square feet. Okay, so x is in square feet. That's perfect so far. Is given by this. Find the cost of installing 50 square feet of countertop. So what that means is they're telling us in part A this. In other words, find the total area under this graph between 0 and 50. So the total cost, you know it's a number, so it has to be the definite integral from 0 to 50 from this function dx. That's all there is to it. And of course, I have to use the fundamental theorem of calculus to determine the number. So 4 is 4. Which function prime is x to 1/3? X to which power? One.
4/3.
Exactly. Very good. Awesome. 4/3. And we have to divide always by the same number from 0 to 50. I flip this into 3/4. So 4 times 3/4, this is 1, times x to 4/3. From 0 to 50. There is no need to plug in 50 because I will get 0. So the final answer is 3 times 50 to 4/3. This means nothing. We have to approximate it. And yes, you can also plug it in and check with the graphing calculator. Okay, where are we? Okay. So, clear? So we have 3 multiplied by 50, and only 50 has power 4/3. And this will be the total cost. 552.60. And this is total cost, which is in dollars, of course. This is in dollars per square feet. Why? Because it's the rate of change. Total cost is in dollars. Any questions so far? Any questions? Okay, part B. I think there is a part B there. Where is it? Find the total cost of installing an extra 14 square feet of countertop after the 50 square feet have already been installed. Okay, so let me explain the idea here. So let's say we have the 0 to, oh, I don't need a second 0 to 50 here. Let's say this is the function. So I already determined this area. How come? This is it. So this was C prime of x. This is not the exact graph. I'm just explaining what this area is nothing else but represented by $552.60. What they want us next is to find this area from 50 to 64. So they want us now to find this area, additional cost. So I have several options. One option would be, why don't I just find the entire area and then subtract this? So if I find all this area between 0 and 64 and subtract this area, I will get exactly the additional cost that they want for installing or whatever another 14 square feet. So all I need to do in our calculations, simply replace the 50 by 64. So the total cost from 0 to 64 is 3/64 to 4/3. Because all I'm changing is the 50 extended it to 64. Once I get this number, I subtract this number to get this number, which is the additional cost for those additional 14 square feet. So I'll plug this in and subtract that. Let me know if what I just showed is clear. $215.40. So I'll copy what we just got. We got 768, and of course this is in dollars. And the additional, let me go to the next page. Additional will be 768 minus 552.60, which is 215.4. Any questions on this problem? And we just got
You
to,
can-
yes?
You can do plug in 64 and the 50 too.
Say that again, Tess. I'm sorry. Can you say it again?
If I put instead of 0 to 50, I can put 50 to 64 too.
Yes. Yes, of course.
Okay.
And you'll do the same thing because you will subtract. Of course. Absolutely. Perfect. Excellent. And this is exactly what we are leading into right now, some properties. So in 4.4, we have properties of the definite integral. And that is one of them. So let's look at an example. So let's say this is the function f of x, and I have a, and I have b, and I have c. Can anyone tell us what is the integral from a to c from f of x dx equal to?
Can you repeat the question?
Yes. So what I'm saying is exactly what we just used, the same principle. This area between a and c can be split into two integrals. From a to b, of course from f of x dx. Then notice that the symbol, the integral symbol, will not exist without a function and without the x, always. Plus the integral from b to c from f of x dx. Is this clear? Is this property okay? And
Yes.
this is exactly what we just used. We determine this area, and we subtract it from this to get this. It's the same property we used. Okay, here is another property. The integral from a to b from f of x plus another function g of x dx. We discussed this. Let's write it again. What if I have minus here? What would you think would that equal to? Will be
Function
it will be integral a to b from f of x dx, and then plus, yes, or minus, depending on, if I have minus, I have to use minus. If I have plus, I have to use plus. The integral from a to b from g of x dx. Correct. Very good. Now, if we want to find the average value of a function on an interval, how do we find that? So let's say we have function f of x, and we have the interval a comma b. This is not the average rate, which is different. The average value of a function on an interval. Here's how we do it. So the average value is 1 over b minus a in the denominator times the integral from a to b from f of x dx. Of course, the function must be continuous on the interval a comma b. Otherwise, we cannot